Flack math! Give me some math and I'll give you some flack. Flack math!
And so we're just factoring higher order polynomials. So basically higher than quadratics and cubics, polynomials. Okay, so far you've only learned how to factor like quadratic functions, like with trinomials and things like that, and a little bit of cubic functions if we find one of the roots. But now we can just keep going with that factor theorem to figure out the rest. So example 1, we're just going to go right into it. You can look at the remainder theorem and factor theorem if you want. Let me just make sure I'm recording here. Yeah, we're good. But example 1 says this: determine if x equals 5 is a root of p of x. And p of x looks like this. So p of x is 2x to the 6th minus 43x to the 5th plus 75x to the 4th plus 1765x to the 3rd minus 857x squared. I'm moving my window here. Minus 22,542x minus 30,240. So this is a big polynomial. So basically, we're just going to plug this in into synthetic division and see if it works. Okay, so what you do here, this big long thing, put the coefficients, negative 43, 75, 1765, negative 857, negative 22,542, negative 30,240, and then we want to see if we get 0. If we get 0, then it's a root. No remainder, right? We're just dividing. So remember, first step, bring that down, then multiply, then add, multiply. I'm going to cheat here. I'm looking in the book. Add, multiply, add, multiply, add, multiply, add, and you're thinking, no way is this going to get back down to 0. Multiply and add. And look what you get. You get 0. So yes, x is a root. So that means one of the factors is x minus 5. Okay, and what's the other factor? Well, this guy. So basically you could, remember, take away an x, so 2x to the 5th minus 33x to the 4th minus 90x cubed plus 1315x squared, yada, yada, yada. Okay, so that we factored out an x minus 5, and then guess what? You can keep going. And that's what this does. There's another example where it's not true, but let's move on to example 2. And you can, and if you just didn't have, here's the deal. They gave you one to try. What if you don't have anything to try? Well, so here's our example 2, which is going to take forever if we do it fully, but we're not going to do it fully. So we're just going to find all the roots. So basically we have to factor, find all the roots of this polynomial. P of x equals x to the 5th plus 4x to the 4th minus 10x squared minus x plus 6. Okay, now if you guys remember the factor theorem, basically if you look at this coefficient and this coefficient, all possible roots are basically this number, all the factors of this number divided by all the factors of this number. Well, this number is just 1, so we can just ignore that. So all the possible roots are these guys: positive and negative 1, positive and negative 2, positive negative 3, and positive or negative 6. So there's basically 8 possibilities of roots in these. And look, this 5 tells us that there's going to be 5 roots. So there's 3 that aren't roots for sure. So hopefully we won't be unlucky and pick those. But we're going to try one. Let's just try one. So how do we try it? Synthetic division. So we're going to put 1, 4. And then remember, there's no x cubed, so you have to put 0x cubed. Okay? So we need a 0 there. And then a negative 10, negative 1, and then a 6. All right? So let's do our synthetic division. 1 times 1 is 1. Add, 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 add. All right, so this is my new polynomial. So basically, here's what we got. So we know that 1 is a root, so we can just say x equals 1. So now let's look at this. So if I were factoring this, remember it would look like this, but you don't have to factor it. If you're just using this synthetic division, you don't have to factor it. So this is x to the 4th plus 5x cubed plus 5x squared minus 5x minus 6. Okay, so that's, if we were factoring, that's what it would look like. But now we're looking at this and we want to find all the possible roots, and we do have a 6 here again, or this is a negative 6, but it's still all the same possible roots. So we're going to try 1 again. Let's try 1 into our new leftover polynomial. So 1, 5, 5, negative 5, negative 6. Okay, bring down, multiply, add, multiply, add, multiply, add. Okay, so we get a remainder. So x equals 1 is only a factor 1 time. Okay? I think I did something wrong here. Oh yeah, this should be 1. So let me scoot back. Multiply 1 times 1, and then add, multiply, add, multiply, add, multiply, add. Okay, so here's another root. So x equals 1 twice, which means 1 has a multiplicity of 2. So we've got 3 more roots we have to find. So now here's our new polynomial. So we're looking at all the possible roots of 6 and 1. Again, same thing. So I'm just going to try 1 more time. Well, if I do 1 again, I get a remainder. Okay, 24, so no. So x equals 1 doesn't work anymore. Let's try negative 1. 1, 6, 11, 6, 1, negative 1, 5, negative 5, 6, negative 6, and 0. Look at that. So x equals negative 1. So x equals 1, x equals 1, x equals negative 1. And then we've got this nice, cute little polynomial, this quadratic equation, which we know how to do this. So here's our other roots. So x plus 2, x plus 3. So my other factors are going to be x equals negative 2 and x equals negative 3. All right? But you could keep going with synthetic division if you wanted to there, but by the time you get to a trinomial, then you can factor that the rest of the way. Okay, so that was a breeze through that. We've done stuff like that before, so I didn't want to spend too much time on it. The next unit, the next chapter is polar coordinates, and this is important. We talk about these a lot sooner in the other curriculum, but they're cool, but there's not a lot of this on like standardized testing, so that's why they put it a little bit later in the book. But let's talk about polar coordinates. This is lesson 96. Okay. So polar coordinates have this r and then they have theta. So basically this is like a vector, right? This is magnitude and this is direction. Okay, so on my coordinate plane here, if I wanted to do like, let's see, 2 pi over 6. Well, pi over 6, remember on the unit circle, pi over 6 is about right there. Okay, so 2 comma pi over 6 would look like that. And it has a magnitude of 2. All right, so that's what polar coordinates are. Now we are going to basically convert polar coordinates to rectangular coordinates, and then rectangular coordinates back to polar coordinates. Okay, and then later on, maybe 98 or 99, 97, you can add these polar coordinates together. But I'm skipping over here. So here's the deal. We're going to convert. I'm going to go skip down to another plane here. I'm going to convert. This is example 1a. I'm going to convert 2 comma pi over 2. So remember that goes the length of 2 in the direction of pi over 2, which is 90 degrees. Okay, I'm going to convert that to rectangular coordinates. Okay, so here's my plane here. So if I were to draw this, then look at, I'm going to just, I wonder if I can just bring this in here. Hold on one second. Ooh, look at that. Can you see it?
You want to move it over a little bit to your left?
Yeah.
There you go.
Ooh, oh my goodness. Well, isn't that cool? Now it's like perfect. Let's see if I can make it bigger. All right, I know you guys are impressed with me right now. I'm pretty impressed with myself. But basically, 2 in the direction of pi over 2. Well, see this pi over 2 here? Let's see if I can go back to drawing. This pi over 2 here. And then we're going up 2. So here's 0, 1. So up 2 would be about right there. So this is 2 comma pi over 2. Well, what are the rectangular coordinates of that? Well, that's easy. That's just 0, 2. You go left to right 0, and then you go up 2 units. Okay? So that one was easy, but let's try one where it's not so much like that. Coming down, same thing here. Oh. Okay, so this one, the next example 1b is basically, we're going to convert 2 comma negative pi over 6. So where is 2 comma negative pi over 6? Well, pi over 6 is right here, so negative pi over 6 would be right here. Okay, this is negative pi over 6, right? When you put a negative sign in front of the radians, you're, instead of going counterclockwise, which is the positive rotation, you're going clockwise, which is the negative rotation. Okay, so 2 comma negative pi over 6. All right, well, if I were to draw a triangle, so that goes 1 unit, this is going to go 2 units, it's going to look like this. Okay, and this is 2, but then this is, remember, pi over 6, that's just negative 30 degrees, or 30 degrees. This is a 30-degree triangle. So if I use trigonometry, I can figure out what this y value is and what this x value is. That's what converting to a rectangular coordinate pair is, by just finding your x value and your y value. How far right or left does it go? How far up or down does it go to end up right here? That's where that is. Okay, well, trigonometry says, okay, sine of 30 degrees equals opposite over hypotenuse, so y over 2, because the hypotenuse is 2. Cosine of 30 degrees equals x over 2. Okay, and obviously on our unit circle, remember that this is our cosine value and this is our sine value. So it kind of does that math for you. So if I were to do y equals sine, yeah, sine of 30 degrees. Well, what's the y value here? Well, the sine of 30 degrees is just 1/2. So if it goes down, it's -1/2. But look, they already give you the cosine and sine values, okay? But it's not just y equals sine of 30, it's y over 2 equals sine of 30 because it's opposite over hypotenuse. And on a unit circle, the hypotenuse is always 1. So when you divide by 1, then that's the value. So here's the shortcut. So if you're converting polar to Cartesian or rectangular coordinate plane, that's what Cartesian is, then you're going to use these formulas. X equals r, which is the hypotenuse, times cosine of theta. Because look, if I were to solve for y here, then I'm just going to multiply by 2. I'm going to multiply both sides by 2. Blah, blah. Oops. And then I get y equals 2 times the sine of 30. Same thing here. Multiply both sides by 2 times 2. X equals 2 times the cosine of 30. So whatever the r value is, this is the r value. It's like the radius. Then you just multiply that by the cosine and sine values. Okay, so that's real easy. So that's my cosine, and this is my sine. Okay, so x equals equals 2 times radical 3 over 2, which the 2's cancel. And so x equals radical 3. Y equals 2 times the sine. Well, the sine is just this value, -1/2. 2's cancel, y equals -1. So what's my Cartesian coordinates? Radical 3, comma, -1. So this unit circle chart is going to be real nice, and you can use this when you do your homework. You're just multiplying your r value, this first coordinate, and the polar coordinates, times these values here, wherever your direction is, wherever your theta is. Okay. So we're gonna go backwards now. We're gonna convert Cartesian coordinates to polar coordinates. Okay. So let's bring up another graph here. Okay. So here is example 2a. I'm going to convert 3, -3. Oh, it's nice when they're the same. You'll see why in a second. To polar coordinates. Okay, so if I were to graph 3, -3, then it would look like this. Over 3, and I'm gonna kind of go big here. Let's say that's 1, 2, 3. And then down 3 is 1, 2, 3. So it kind of looks like right there. Here's 3, -3. All right. Now, if I bring in my unit circle, well, first of all, I could draw a triangle here. So here is this, and I want to know, because this is over 3 and down 3. You guys remember what kind of triangle this is? This is an isosceles triangle. So that means this is a 45, 45, 90 triangle. So the shortcut here is 3 radical 3. So that's our first value. That's our first value in our polar coordinates. So now we just need this direction. Well, that's just 45 degrees, but we're not going to use this. We need to change that to radians. Well, let's look at our unit circle and see what radians it is. Okay, what radians is that? Let's see here. And it looks, so 350 degrees, so 7 pi over 4. So we would have 3 radical 3 and then 7 pi over 4. All right. Oh, it's not 3 radical 3. Did anyone catch that? In a 45-45 triangle, this is 3 radical 2. I'm thinking of a 30-60 right triangle. So 3 radical 2 is is our R value. Okay. And then this one, looks like I got this one wrong too. Oh, I wrote down the wrong problem. It's supposed to be -3, comma, -3. But this, if it was 3, -3, then this would be your answer. Now, there is a shortcut to this as well. So your tangent, remember your tangent, you can also determine your tangent. Tan of theta equals y over x. Okay, or your sine over cosine. So your r squared, and then you can use the Pythagorean theorem. And that's what we did here, but we know the shortcut to 45, 45 right triangles is just tag on a radical 2. Well, we thought we knew it, but I forgot it. Okay, just momentarily. But you can use the Pythagorean theorem. A squared plus b squared equals c squared. That's how you can find your r value. And your theta or your radians is just going to be y over x. Okay, so that's just, yeah, your y value and your x value. Yeah, so tan of theta, and then you have to do your inverse tan to figure out what your theta is, right? So your theta is going to be the inverse tan of y over x. But a lot of times you're going to end up with a nice pretty one like a 30-60 right triangle or a 45-45 triangle. And you can just look on your unit circle, because this unit circle is awesome, but it only deals with 30-60 right triangles and 45-45 right triangles. So there's only a few values. But if you were just given, like, instead of, maybe it's like a 3 and 4 or something. Well, 3, 4, 5 right triangle, you would have to do this inverse tan to figure out your theta, okay? All right. And then example 3, you're just graphing r equals 2. Well, in a graph of that, the r is just the length, okay? So if this was my graph and I want to graph r equals 2, so that's just radius equals 2. Then if this is my coordinate plane here, so here's 1, 2, 3. Well, r equals 2 is just going to look like this. It's just a circle with radius 2. That's what r equals 2 is. It's kind of silly. All right. And then graph theta equals pi over 6. So here's another kind of graph where they're just asking you to find theta equals pi over 6. Well, pi over 6 is just about right there at 30 degrees. So you're just drawing a line at going 30 degrees. All right. In the past, we would call this slope, but in polar coordinates, we have an actual degree or a radian that tells us which direction to go. So if you don't know where pi over 6 is, you can convert it to, you convert pi over 6 to degrees if you want. But it's just multiplying by 180 over pi. But that you should be able to find these on your unit circle chart, so you should be good. All right. So this was short today, and I know you guys are crazy. So if you have other things you need to do, other homework you need to work on, that's fine. If you want to work on some math, you can. And I can give you some Flack Attack coupons if you get some problems done. Usually we go bell to bell in Algebra 2. So that lesson 95 was a little easier, and for some reason it's faster on Zoom. But so if you guys want to do some problems, I'll give you a Flack Attack coupon for every 5 problems you do. Then you can let Mrs. Waite know. And yeah, I'll figure it out. Good. Any questions?
Black math, give me some math and I'll give you some